Hi everyone, this video is for section 2.2 and it's basically going to be working with solving different forms of equations for a specific variable. So I'm going to go through three examples with you in this video. The first one that we're going to look at is 3 times the quantity of r plus 1.6 minus 8r is equal to 9.5. And what I want you to be aware of is when I am saying the term quantity of, I'm actually referring to those parentheses around the r plus 1 and 6/10. So in order to really begin to do this work, what we want to do is we want to try to figure out a way how to get rid of these parentheses. And what I want you to note here is that the 3 that's being written next to it is actually being multiplied with that entire quantity. So the way for us to get rid of those parentheses would be to use our distributive property. So we're essentially going to be doing a 3 times r and then a 3 times 1 and 6/10. So if we do that, 3 times r will give us 3r. I can't really go any further than that than writing the variable and the number right next to each other. That implies multiplication, and as you all probably know at this point, if it's a variable, I don't know what that number is, so I can't confidently multiply those two and say what number would result. And then on the aside that I'm going to do, which is basically me just thinking on the side of my paper, I'm going to do my 1 and 6/10 times 3. So 6 times 3 is 18. But I want to carry that 1 over into the next position over. And then we're going to do 3 times 1, which will give us 3. And then we're going to add that extra 1 there, so I have 4. And then this is just a refresher. Note that we want to count how many digits there are after any decimal points in the problem. So I only have one number after my decimal point in this multiplication problem. So I'm going to take the decimal point of my answer and also move it in one position. So this means right now I have 3r plus 4 and 8/10 minus 8r is equal to 9 and 5/10. So the next thing that we want to do is I want us to focus our attention just on the left-hand side. And what I want us to note here is that we actually have like terms. So I have a positive 3r and I have a negative 8r. So I can combine these like terms. The result that we end up getting here, so a 3r and a negative 8r would result in a negative 5r. Again, we want to make sure that terms are like. The variables that are next to our numbers have to be identical. That means that one cannot have a different variable next to it. It can have multiple variables next to it if the other one does not have the exact same variables as it does. And one cannot have an exponent attached to it if the other does not have the exact same exponent. And again, just as a refresher, if you think about this in terms of money, if I owe someone $8, but I only have $3 in my pocket, that's why I chose to write negative 5 times r. And then as we go along, we will still have our plus 4 and 8/10 on the left-hand side, and then we have our 9 and 5/10 on the right-hand side. All right, so now let's go ahead and keep going. So my goal in this whole process is to make sure that r is isolated. In other words, r is the only value on one side of the equation. It doesn't matter if it's the left side or the right side. You just want to get the variable alone. So in this case, I'm going to choose to go ahead and subtract 4 and 8/10 from both sides. And I'm going to have to do a little bit of borrowing here, or regrouping. And then let's see here. So 15 minus 8 is 7. 8 minus 4 is 4. And then we also have negative 5r. Okay. So as we keep going, what I want us to note here is that, again, we have a multiplication that's happening between the negative 5 and the r. So to break multiplication or undo it, I'm going to divide both sides by that negative 5. So again, I'm going to come over here and do some work on the side. So if we're working with a division problem that reads 4 7/10 divided by -5, we don't want to leave our answer like this. It's like bad math grammar. We don't want to leave a decimal in a fraction form. So what we will do is we're going to go ahead and continue our work. And I'm going to rewrite this as a division problem with the box format. So what I can tell you right now is that 5 cannot go into 4, so that's why I'm going to put a 0 here. And I want my answer to mirror where that decimal point is. So now I want to ask myself, how many times would 5 go into 47? And I can say, well, that's 9 times. I'm left with a 2, so that means that I can keep going. So I'm going to place a 0 here. So 5 can go into 20 4 times. So our result here is 94 hundredths, but we want to be careful because, again, we're doing a positive number divided by a negative number. So our overall result should become R will equal a negative 94 hundredths. All right, so let's go on to the next problem. So the next problem that we're going to look at is 53 is equal to 8 plus 6 divided by z. And what I want you to note here is always focus on the first question should be, how can I start this problem? Is there a first step that I can safely execute? Because odds are, if you look at this problem and you are kind of feeling like wires are crossed or you're feeling a little fried mentally, it's because you're focusing all your attention on the fact that you have a variable that is now in the denominator and you maybe or maybe do not feel confident on being able to get it out of that position. What I would say is, let's focus on the 8 over here. I want to clear it. So to begin with, I'm going to remove an 8 from both sides. So if we do that, again, I'm going to regroup. That's going to give me a 5, and that will give me 4. So my new setup, I'm going to change my colors here, will be 45 is equal to 6 divided by z. There's a couple ways that you can approach this problem. For example, what I might choose to do is, I don't want my variable in a denominator. It just makes it that much harder in order to figure out this problem. So what I might choose to do is undo the division by multiplying both sides by z. And maybe now that you've seen this step, you might be kind of saying, well, what good does that do? I can't multiply 45 and z and get a number. And the answer is, you are correct. You won't get an answer, but it basically allows you to put everything all on the same playing field. You no longer have to deal with a fraction. So the good news is I'm just going to rewrite this problem. I have 45 times z on the left-hand side and 6 on the right-hand side. So now hopefully what you're thinking is, oh, so now I have this multiplication, I can break that multiplication with a division of 45. This is now going to give me z is equal to 6 over 45. I do want you to make sure that you stop and reflect on your answer. Is this as simplified as possible? And hopefully you're saying, well, I think what I can do is I can divide a 3 or reduce the fraction by 3. So that would mean 6 divided by 3 is 2, and 45 divided by 3 would give us 15. Here, I know that this is my answer and that I am done because I cannot reduce this fraction down any further. This is known as the 2 and the 15 are relatively prime. In other words, they don't have any common factor that we can reduce by, much like 6 over 45. That has a common factor of 3. So since they have that number in common, they are not relatively prime. So let me actually go back to this step that I have in purple. 45 is equal to 6 divided by z. And this is a different trick, but it should take us to the same solution. What I'm going to do is I'm going to go ahead and write 45 over 1. So right now I have a fraction equal to another fraction. So this is an example of a proportion. Perhaps you've seen this before in previous math classes. And what I want you to note is I'm going to do essentially a quick trick called cross multiplication. So I'm going to loop the 45 and the z together, and I'm going to loop the 6 and the 1 together. The result that I'm going to get is going to be 45 times z is equal to 6 times 1, which gives you 6. And as you can see, this result takes us right to this step in our previous work. As we go through, we would do the same thing and divide both sides by 45, reduce that fraction down, and then we would also get 2/15. All right, so last one. We have 3 is equal to 18 plus n divided by 44. So what I want you to note here is that there are a couple of ways that this problem could have been written for you. One way would be I could have rewritten this as 3 is equal to 18 divided by 44 plus n divided by 44. I just want you to be aware that this section here, where I have that whole division over 44, is a shorthand for how this problem is written. So this may not actually be massive help for us, but I just want you to understand that there are different ways of writing the same problem, so that they are still saying the same thing, they just look different on the surface. For this particular problem, though, again, I'm essentially bothered by the fact that I have a fraction here, and I don't want to deal with a fraction if I can avoid it. So what I would choose to do here is, if I'm essentially taking this entire 18 plus n and I'm dividing it by that 44. So I'm going to undo the division and multiply both sides by 44. So this is a bit of a bigger number, so I'm going to do an aside, and I'm going to do my multiplication here. So 44 times 3. 4 times 3 is 12. I'm going to carry my 1 over into the next position. And then 4 times 3 is 12 again, plus the 1 is 13. So my answer here will be 132 is equal to 18 plus n. That trick alone of what we just did up here allows us to kind of go back to a simpler form of solving for an equation. So the last thing that I'm going to do, since I want to get n alone, I'm going to remove an 18 from both sides. And this is going to isolate n. So in this case, I will regroup. 12 minus 8 is 4, 2 minus 1 is 1, and then the other 1 is just going to come along for the ride. Here is my final solution. So what I want to kind of leave you all with is that remember that you can check your work before you submit or call it done. So for example, I might go back to my original problem, and instead of writing the n, I'm going to write the answer that I found. And then I'm actually going to start to clean it up. So I would do 18 plus 14. Well, that's going to give me 3 is equal to 132 divided by 44. And again, what I want to note here is if I've done this correctly, then 132 divided by 44 should be the same thing as 3. And as we can kind of see from above here, if I did 44 times 3, that would give me 132. So this is a confirmation that my work is correct. So I hope this video was helpful. If you do have any questions, please let me know.